So hi guys, it's me Yui, and welcome to another videos. Today I'm gonna make uh, an HTTP server in C++. I actually made a video, but like the previous video, I was just like sit there and code. I wasn't like speak at all. So yeah, this video I'll try to um, speak as much as I can and try to explain everything I did. And okay, so let's head in. So um, before starting, we just wanna know if you guys know or you guys don't know. So an HTTP server is um, just a server that um, accepting requests, especially HTTP requests from clients, and it will um, like return response. And it's like if you guys been coding, you guys will know React or maybe any backend server like Fast API, Django, like literally every backend server will have something called HTTP server that basically you run the server. Then the client can do some requests. We can query, we can send some requests and server will respond. So yeah, it's basically an HTTP server. And so um, I will explain what um, how to make how to create an HTTP server. Um, so we have to understand something called a socket. A socket's really important in HTTP server. Um, a socket is basically um, um, let me search. So um, the operating system will open a screen, like it would create a screen that allow connections. Yeah, it's basically that. Um, and a socket, it's like something in between the connections. It's like when you're borrowing a book, right? When you're borrowing a book, um, so uh, the library will give you something. It's like a sleep number of your book, so it's know that like how you return your book or how you borrowing your book. Like you can borrow, keep reading, returning your book. It's have a number, kind of like that. So like this is sockets. Yeah, sockets like um, you guys will understand if when I go over like coding my projects. So yeah, this would be a side project just to mark that I learned C++. And then after we have a sockets, we will bind the sockets. We will bind sockets with like more information. So the socket exists. So we create a socket. We have a file descriptor um, to contain uh, the information of that socket that it exists. Because when we creating a socket, that the operating system will return something called it's just like a number that label our socket exists. That we will use something called a file descriptor to store it, and then we will bind. Bind is basically you um, letting that socket allowing what kind of network, like from the Wi-Fi, from the Ethernet, Bluetooth, and we also assign the port for the bind, and then after we bind, we will then make our sockets and listens to the client and also accept the clients. During that, we can also like read or write client's request. So yeah, let's hack into it. So here I'm gonna create a new project. Let's name it TVP server. So let's into that. So we want um our C++ project, as always, will have an include folder, um, a source folder, and we will need a CMake. Yes, right. S S S. Um, if you guys don't know what is CMake, I recommend spend like 20 minutes to learn. It's not that hard. So CMake is like if you have a decent amount of C or C++ file, you will want to use CMake to kind of build, link, and link our file, because we just can't do it manually like this, right? Um, so yeah, missing anything? Nope. So now let's create a file called http server http, just like this, and I will go step by step. Just make sure if you're watching the video, you understand what I'm doing, and it's yeah. Um, so we will be using something called sockets. So that's why we need the socket from systems. So this is methods from process and operating system, if you know. Um, so we create main and return 0. We will create a file descriptor, the file descriptor, and then we call sockets. We will then um, um, set the sockets into like this is the IP type, and this is basically a next in IPv4. The type would be TCP, right? If you don't know what TCP is, I recommend have a look on Google or something like that. So this is socket string, meaning we are using TCP, and we are using a default protocol. So um, our operating system will turn this for us. So after doing this, we can then print our sockets, right? We need something called um, lines, and we would want to close our sockets. Just make sure that we are opening the screen. Then just remember we always have to close it after that. Yeah, undefined. I don't remember what's the close for. Super plus. Let's see. That's good. So this. You, yeah. So then now we tested if it works. So let's settings our CMake this. So this is where we will start configure our um, CMake, and we will want to setting the versions. So let's do CMake. I think it's minimum versions or minimum reply. And our versions, I want to check if we can do CMake that's versions like that. It's a 4.2, but we will I would recommend using a downgrade of the versions select 2.2 because we ensure this is gonna work on like every system, right? If someone did not update the CMake, it's still gonna work. And then want to name our project. Um, let's say let's name this HTTP server. HTTP servers like that. And then we want to set the versions of the C++, and I would recommend doing C++ 17 because it's the most modern C++ for me, and it's actually making later on we will use we will create a wrapper for the sockets, and we will then have to um, delete some of the methods like we don't want people or we don't want like the program itself to copy the sockets and to actually make the coding like easy text look clean and easier. So that's why we are doing cmake dot cx and we do standard. We want to be 17. This is equal to 17. Nice. Is that slash like that? 17. And then we do cmake standard required on, and finally add executable, and before add executable, yeah, we add executable, and then we're gonna link the include folder, which is the header folder, into our applications. Just name this to our HTTP server. It would be source dash HTTP server dot cp, right? We need a dash in between s. Let's save, and now we go down with target each directories into we will want to name TTP server, and then Firefox, right? And then include just like that. And if we do I don't remember we did this. That's it. Okay, so then we will create, yeah, a directory name builds. We will do cd builds. We will do cmake. I forgot because our cmake file is actually outside of this folder, right? And then when we want to cmake that builds. Okay, so we quickly built, and it's already linked whatever it includes folder that's successfully compiles our file, and now we can do, if we do ls, we can see we have our HTTP server applications. We can do // HTTP server, enter. So this actually remain return free. You know why? Because we have three for like pre-screen that already registered by our system, which is um, if you guys don't know, let's quickly go over it. It is called SD out. Yeah, it's SD out feelings. It's like uh, the stream to output in the OS system. It's kind of outputs um, to our screen. And we also have something STD in fields. This is for input from the keyboard, and we have STD for fields, which is um, what is this? Is that the output screen? Yeah. So basically, this the error is being registered at 0, 1, and 2, and we just open the socket, and it is registered at 4 as 3. And if we later on register another socket, it'll be 4, 5, and 6, and so on. So now we sort our XMPP server like that. Now I will demonstrate how we bind um, how can we bind the port, um, the IP into our actual sockets. So we will do let's just do this. It's something called sockets address address. So this is the struct. The struct. If you guys don't know what struct, it's because it's a struct returning including the family, which is the address family, which is the activity for admissions, and we have this the port and the address, right? So now we do create for this, and then we have to include something. This we have to get it's h. So let's include it. Let's h so like that. Now we call it address. We want to initialize our address as empty. This we have our family, everything as empty as a default because we don't want to initialize it with garbage value, right? So that's why we kind of need it open in close curly brackets. Now we will do address dot family equal to AFNet, which is IPv4, and then we do address dot port equal to ATONS. We can do 8000, 8080, and 8080 because it's a convention. What is ATONS? ATONS is it's a short term of what is H network online but H time is basically it will short the bytes of um the CPU because our CPU provided um the byte for and we have to short it to fit the network convention because different CPU including NVIDIA, Intel, we're gonna have a different convention in how bytes being regulated. So we do a time. So time is a short term of host to network short, and you guys can see it say that it's convert the bytes um, into a network byte order, because we want you understand that basically network, um, how we um, let's say transferring data from here to there, like it through the network, it's all about bytes and it's being converted in several layers, but like the lowest layer, which is being converted in, which is being sent through the network is bytes, and so we want to convert that into um, a network convention. It's gonna work, and then we want the address dot uh, socket internet address dot s address um, equal to address any, and it's basically we allow any type of address from the network. It can be from somewhere else or someone in using the same Wi-Fi to connect. So now we can, after we do this with the bonds, um, we passing our scripture. This would be our socket address, right? So with this socket address, um, this going to pass in our address. This would be uh, size, left side up, and this size up. So it's going to be side of our address, right? And this is going to return something. Um, so we're going to check if this equal to F1, which is failed. We will return F1, return 1, and we want to erase the error. So we use computer error. So now I think we use the final standard C library studio H. So this is what now. This would be the error points, right? Okay. You also want to close this here if it's not working. You also want to close this here if it's work or not working. We also want to close it at the end. So it's the CS one successfully. So let's just see it still, and we call our attribute. So one is invalid argument. So we actually have the error, which is we are passing invalid argument inside our bonds. Still string. Well, I think there's something wrong here. Negative one outside, because we compare it here. Like that. Just do it. Let's see. Let's still and call. So so yeah, it's a bind successfully. And now what we're gonna do is that we gotta make a listens. CD statement. Now we make a listens, and listen actually return something, right? So we do int finds that finds listens, listens finds listens equal to listens. We passing our this, and this is the connection to this one of 5 at most, and just like that. And it's any error. Do its return or like this this plus. So yeah, this is not gonna return anything. So we want to compare it immediately, like directly. So we want it's smaller than 0, which is -1. It's gonna be the error. So we just return 1 and we're erasing the error. So we do error reset listens. Just like that. But else we let's say listening like that. If it's there one post it, right? Post it like that. And we just like that. Built. Oh yeah. One we don't want this. Okay, so we do it. So say listening, right? So we have successfully make our sockets um actually starting to listen. So now let's do that thing that then to the server. Now while we listen it now we can want ours um thing is that it just listening like our HTTP servers can now listen, but it's cannot accept yet. So we want to actually make it accepting the clients, right? So what we're gonna do is we will use the accept method. It's like that. socket stage. So we can do like listening here, right? And then we just start accepts. Let's see our listeners set empty. This will be listening from UPTR because uh we want our uh our TCP server to listen to everyone. Our PTR. Just like that. And I think it's also return like the error like that. So then we just can't like oh what do we do with this? Bro, oh wait, it's flashback. Oh, sections. See the listening everyone sucks. That be PTR in PTR PTR and the ones is that we raise the error naming it as such. And you can say um return something with a find connected. Um not impact. So well I'm not sure it's after um this we can do with accepting. Yeah, okay. Yeah, that's alright. Let me call it right. Let's see. Oh, save. Maybe do see it one more time. And file server. It's listening if I open another another terminal and see a code to our local host. As it is. We'll say it's return connected. Well, the receive is failed because our HTTP can just now listens accept the connection, which is not returning any response yet, right? So now, let's go back to our file. We can try to write a response to our clients. So, um, we can actually do this. We do not int after like that assign to our lists. So after uh, so now we can pass this time after state, right? And this is also listening from our times FD. And now we can do like we will write something to our time FD. It's gonna be a response. We create a response. Um, or we can actually do let's do this way, just like that. And let's say response equal to let's see, slash 1.1 slash um, okay, something like that, slash r, and then you can say something like find type, right? C++, UI, like the name, and then return okay. Now, for this, we are passing in our response, but we need to convert it into C string. Because why? Because this method writes is not from C++, but it's from C instead. So that's no, it's from the operating system. So that's why um, we need to convert it into C because it understands C, not C++. And for C, of course, it's gonna be SCR. No, it's gonna be size. I'm not sure. But let's see. I think it was uh, respond.size. And then yeah, let's do CMake split having an error. Say in function for me. Um, so stable. So so we are mixing a parenthesis. We do not need that. Yes, we have certain. Oh, we have an error. Software operations. Hmm. 1 is equal to this. I think we cannot like kind of use this. Let's see this. I think this is a good implementation. So uh, this is actually success, but then the error is here. Um, don't think something from here, to be honest. And we didn't even like that because of the odds. Is the so oh, short name. Maybe because I renamed out the five scripture into times five scripture, so that's why still got left. So, oh no, so, so hmm, maybe I will need AI to look at. Yeah, I think this is I was wrong because we can make this listen and then after accepting we can then assign it into a new files. So here we keep that um, as this, which is we can do listens, right? But like that, and here we can then um, using influence of the equal to subs passing this new PTR, yeah, just like that. Then then that with the and studio. So if I do a post read, um, let's say imported xvp dot slash so person response um would be having some problem with response. So so let's see if there are any errors. String response. Yeah, anything wrong here? We need the status, but it's not necessary because we are determining like this is our server. I don't think so. Matter. Uh, this to still there's an error size 2 because it's have to be positive and equal to this. Okay, now we can do if and is lower than 0, which is can't be equal to return once and erase it. So see. Okay, so it's actually return just return pay, right? Right? I saw that. I saw that. Yeah, so it worked. If we um let's say this can be welcome to the server. Second, that see let's let's do this we'll do a curl with the host. Uh, so let's return we which is welcome to the server. Um, so yeah, it's work, but maybe we have the length to be short. So we change the length into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 18, 18, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22. See, still that already got slack. So, and so let's return welcome to server, which is great. So now, um, this is basically a simple HTTP server, but now I'm gonna make a wrapper so that our each socket can automatically close when it is being destroyed or go out of the scope. This is called ARII. You can search it on Google. I'm not gonna explain it here, but basically it's an idiom. It's a like it's a how can I call it? It's like a mindset. But here, so now we actually starting to create our wrapper. So I'm gonna make it faster because it's pretty late now, and I can speak no more. It's pretty hard. Uh, so let's do room includes. We will call it socket.app, or we can call it wrapper or whatever you want to. So now we want fragment once. This means that it's gonna define. Um, it's gonna declare everything just once. Just make sure that includes USD, the H, to our class. We create a wrapper for our sockets. So now we want to explicitly destroy our sockets. We want to in the file descriptor, and then we immediately initialize it here at the like that, and just make sure that this is the couplet effort, right? So we want to have our private. So here we want to instruct. We want our file descriptor to be private. No one can change our file descriptor from outside. Just the method itself in the class. So as I mentioned before, this is why we want to use C++ 17, and this is why um, we want to we don't want to um, we don't want our socket being copied, right? Because imagine if there are two variables the same referencing to the same sockets is gonna cause conflicting and error. And if we are posting uh, this variable but another kept still. Um, so that's why this is cons sockets, which mean that this is another this is sockets equal to delete. While in other C++ versions, we would have to put this line into the private. That means that we have disable the copy feature, but in C++ 17, these methods become more intentionally that we can see that we want to delete that. We don't want to use that. So then we want sockets. There's another way to create a copy, which is using the operator, like using uh, so a variable and then equal to existing sockets. So that's why this is not a way that we're using operator equal and is equal to another existed sockets. I might want to call this. We want to use that later. So be our sockets, right, equal to our existed sockets. So we want this, that, and then we delete that, right? But, and um, now we want to enable. We want to custom our move method. Um, I will code first, and then explain why we need that sockets. This is existed sockets. Other no except we don't want to raise no exceptions during this period. So and then we want to initialize the new file descriptor that we're passing the file descriptor of the existing um, socket that we pass into, and like that. Uh, and after we passing uh, the existing like the old socket into new one, right? We wanna set the old one into -1, which means that we completely killed the old socket. So now, after every single like using like listen that sets, we always having an HK that check if that file descriptor is -1 or not. If it is -1, we're not gonna do anything and return the negative, right? And there's actually another way that if uh, the socket itself is existed, let's say B is a socket, A is a socket, and now you move A to B, we would want to terminate B first and then assign A to B, right? So this is here other. Nope. This is we are using operator equal sockets out and set. So if this is not equal to other, like if it's different to the existing sockets, and we first want to close it, then assign we assign the file descriptor of that of B with A, right? And then we're gonna close A, we're gonna kill A, completely kill A, so just make sure that no one can use A no more. And then we're gonna return the value of B, new B. Yeah, so with this, wait, this is something B. Yeah, Okay, cool. So after this, we want something called a deconstructor. This is why this is RAII, as I mentioned. Just basically this wrapper. If we deconstructor, which means the socket the sockets have in its its scope, like go out of the scope or terminate it, we will automatically close our sockets. So that's why in later on in the main function, you will see we never need to close it because it's automatically being handled here. And we want a functions, a method called fd, basically return the value of fd because later on when we are wrapping, um, so we are wrapping all of the file descriptor we pass in this socket object, it's become an object, but we will have some object, we will have some method like write or read that it's actually need us to like give it the value of the file descriptor, which is the label number. So then we will have to return the value of the file descriptor because it's an object, right? We wrap it, it's become an object. So that's why we always need a function to return the value of file descriptor. So here we would have non-functions and close it like that. That we, if it is not -1, which is exists, use the global close functions to close it, and when a set is equal to -1, just make sure we kill it completely, right? And at the end of class, we want to a semicolons at the end of class. So now, head out, let's do zoom for so this. So we want to include move it to the upper, so that includes socket.fpt right there, perfect. And now pretty much we kind of have to change our code a lot, but actually make the code become way clean later on. So um, that's about understanding everything. I just kind of delete everything, and we will be rewriting everything from scratch. And but trust me, it's gonna be easier, faster, a lot. So we want a new raw alpha scripture that equal to our sockets, right? It'll be the domain, which is IPv4. The type gonna be sock string right there. Sock string. Yeah, this is gonna be 0, and then semicolons. Now here, when the wrap it with something, we can call it sockets. We listen to it. Yeah. That's why we want to pass now. We want to pass the value of, we want to pass the file descriptor basically into this wrapper. Beautiful. So now it's have all the features that we created. Now, but we still need to uh, set up our um, socket address, which is I'll do this quickly. So now we will our bind our listening sockets with our address configurations. And because our listening socket is now an object, we will have to use the FD method to get the value of the file switcher. That's why we need that. And then everything is the same. See here, and then size. It's just like that. And we want to listen, right? Like that's the same thing here. We want most five um, lines. I'll say listening. So that, and let's say SCBCF waiting for actions, and lines. We already go over all this, so I'm gonna go over this quickly. We set passing our listen socket, right? So yeah. Now we want to wrap it, right? But before wrap it, we always want to um do the error handling. So if it's not gonna fail, like obviously, but we kind of want to do it. Let's see like, if this is equal to negative ones, just make sure we have the error handling return. It's fine. Same thing for this. We want to error this early listens. Oh my god, suppose that we do not need some calls here. So this thing, and now we want to um wrap it. We want to wrap. Before wrap, we want to check if our lines at least is equal to negative lines. We're gonna erase error. So, and now we want to wrap it with sockets. We want to say lines, socket, and wrap it with our lines at the, but we want to move it. Right? This is why we using move. Um, we are transferring the ownership of clients at the inside this little object sockets. So if um, like every single time um, after if it is being handled, like I mean socket it's like terminated, like the process is complete, it's gonna automatically post the clients, post the sockets, like everything is doing like um beautiful, like everything's handling automatically. So now we are print um times handle, and we want to have the functions. Well, maybe I can quickly remove this. Maybe we don't need this for now. Wait, we create the buffer times 48. Just make sure that now we can read um, from the server, like from the clients. I mean, so we can do create a buffer like this, right? Um, Charles, exactly Charles buffer. So we do reads is we are passing the clients. So gonna be the buffer. It's gonna be buff the size of the buffer that forms. And for this is the side T of n read this uh, this function will read the climb the class and write it into the buffer. Or set the buffer and um, buffer write reads and return the size of what is have read. So the size of the last one gonna be this backslash zero. This we are using this to it's as a way to terminate the string in C, if you guys know, and then we we can then print CF. You see, let's say this, you know, buffer. So just make sure that everything's working. I want to rush and I can write straight SCDFP response and start P dot one to eight. So that can to be 10, but to be, let's say hello would be 5, so 5, that 5, and this time return welcome, then return hello, and we're gonna write it into times on FE. find dot c3 SCR size resize discovery response size change it right pause it before because we didn't wrap finds in inside the wrapper yet, but I just want to demonstrate for y'all. Just hey, we are having the error LBSA. It's impossible to code this much without error rate. My ESD size. It is fine. Still likely. Besides, really, you know, size off, right? Line 10, I think this is side off. See what we do. Oh yeah, okay, okay, yeah, makes sense. Like this, and we'll need that to submit again. So software folder in our header file. Um, oops, graphics, spec, spec, oh, this is it. Into shift. So now it's waiting for connections. I can do a code, say do local host 8080 So yeah, it's working. Cool. So see, we have I have add a wrapper in its work. So now we're gonna quickly um, finish our project. Um, for HTTP server, I will be adding the timeout and also the thread. So just gonna make it quick. Um, so yeah, um, just delete that. We don't need first. So after we handling the error of creating our client, right? We will find it. We will wrap it with a socket object. Uh, so say socket times FE, right? So now if you um, just have functions here that we are handling the timeouts, so yeah, like that, and and the request. But here's gonna XDC out. If say finds is being handled the way or not waiting for another response because later on we will be looping. We will put all of our code inside a while loop. So to make sure that we can have a real FTP server that accepting requests from many clients. So now we're gonna have to create our methods, which is in our timeouts. Um, this is our timeout handle that we are accepting um, the file descriptor in the second step. We want time like how how long we want our HTTP server to wait for uh, a request that not sending anything. So this is the timeout struct. Um, TV sec, we want to set it into our second, right? This is the you set is the microsecond is gonna be zero, of course, um, because we want our second to be like an integer like 5 seconds. It's not like 5.2 or something. Let's set something out. We're passing our sockets. Um, the level gonna be the solve sockets, and the type would be so. This is RCE Gmail. This is the method like reads. Yeah, and then we passing the value of our time out, and this is the size of our time outs. Like that. So ones, this would be what the fuck would be sockets? Socket, right? Socket, right? This would be send because this for the timeout for the send and the accept method, and everything else is basically the same. And in our handling requests, we will want to um, pass in our socket object that's gonna handle the 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 client's socket for us. So we want to set the timeout here, pass in the client's got the value of our clients. We for now we only want 5 seconds, and that. So then the buffer that I just demonstrated previously, this is buffer that we store at the request um, body. So now, see body eats to each rate this factor rate minus e buffer side 1 like that. And if y is negative, then we want to handle our error. The event works can be something called this. So got SDBC out is defined timeouts like else gonna be we don't know the error, so it's raise the error based on the system and return. So if our byte width if is equal to 0, this means that we disconnected. This is CF disconnected. Turn and set our buffer the last like at the end of our buffer we want a terminate key terminate, so it's like C type as well. And after that we want to print it, right? SCD the CSD out. We can do like the receiver request, or we can say yeah receiver request. Back to serve the M lines like that, and now so it's gonna print the request into the TP server, and now we want to create a response. Now response is actually equal to that I already did, so we just say b 1.1 to be okay. Continue the state of codes, which is tune the success, and we do runtime and let's say that. So we're gonna write into our client because it is now an object, the sockets up here. So the value of that our response dot see that and response dot size. It's like that. Perfect. And we go down here. We will want to call it handle request and pass in our SDB move. This is where we're using SDB move, the move functions, and we're gonna pass in our finds sockets. That is, we are moving the sockets here, transfer the ownership to this function. So if this function is done, it's gonna automatically close the prime socket because it's already going out of the scope of that function, right? So now we can save, save that still, do that, and of course we have error. Integer, the missing. So it's resume. Got me back to server. Integer. Okay, we can see it here. Let's spot. Ouch, my back is so hurting, bro. Now we do code per course. And let's test this the timeout because we just try, right? We can do like NC localhost 8080. So if we wait for 5 seconds, it's gonna be timeout in this our server. So yeah, you can see it's timeout because we are not setting anything here. And you can run it again. It's already in use, so we might have to wait a little bit. Uh, see, students, yeah, so so the reason is that despite we already handle our socket, but like after folding the socket, the operating system will need like 30 seconds or a minute um to make that socket ready again. So I just do it. Yes, now it's work, right? You can see. So now we can try do a post request. Let's try so 2 hour load to do such steps. Just do maybe 1, 2, add this URL reject. Oh, you're missing this. I think we need this like Gatsby. Um, yeah, we need it. Bro, I'm so new. I'm so dumb. Let's go back here. That's so you see, our activity survey successfully received a the request and then bring it to the screen. And now we need to add a little bit more to make our activity survey become perfect, which is the thread, um, the thread and a while loop. Short, so, so you can see here, we are doing like every single time here, right? We After we receiving a request, we close immediately. But as a FTP server, we want our FTP server to keep accepting requests from the client. So we add a loop here, just like that. Um, so now, perfect. Our HTTP server. Someone can tell us. So our HTTP server um, can keep accepting requests. If we go here, if we go select, oh, here goes the field, select that, and select and server. If I do phone with the host, let's see, it's keep getting response. You see, cool, just like that. I can call the previous method like that, as it keep accepting requests from the clients. And now, last thing I'm gonna add our to my project is that I'm gonna add a thread. It's really easy, really fast, but it's a significant, massive upgrade for our ITP server, which is called thread. So thread is concurrency. Basically, concurrency is allowing our HTTP server at the same time allowing multiple clients to connect. So here, just gonna say SCP threads, select that, passing our functions, and um, targeting which is SCP move our find software insights, and we want to detach it. We want it to run independently. So let's try it. CD build, we do submit, right? And now, if I open our terminal here, um, so basically we can do requests like this, right? Let's say, it's like this, right? And I will prove that this is a concurrency. Now I'm gonna use the netcat to um, sending a request with nothing is gonna um, if our HTTP server not having track feature, then if a client connect to it, all of the other clients will have to wait until um, the first client got processed, right? So now I'm gonna do here, I'm gonna delay, and just right here, I'm gonna make another request. So basically, I'm gonna, let's see. So it's better to have like this, so you can see it. Okay, so I'm gonna here, enter. It's accepting another client response, enter. See, it's 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 basically a thread, a concurrency. It's doing accepting multiple clients at the same time. Then you can see that as though I run this timeout first, it because it's delayed, so it's return later, right? I mean it's respond with a timeout after this, even though I run this first, so it's approved. So yeah, um, with that, we have our activity server in C++. For a future upgrade, we can try to add a thread call. A thread call is basically we are firing a socket and we're using that socket to save the resource, right? Because basically now we are using a thread. It's good, but lots of thread gonna cost a lot of memory because it's just keep firing and having a new socket, right? Okay, so yeah, it's pretty. Oh my god, it's 2 hour. So hopefully, see you in the next video. Goodbye. Peace out.